It is my great pleasure to welcome you to the world of learning new concepts and current trends, so let's start. A database without strict rules accepts any data you throw at it. Over time, corrupted inputs and broken links accumulate, creating structural weaknesses that render the entire system unreliable. In a live environment, these vulnerabilities lead to inaccurate reporting and lost records. For your coursework, leaving these gaps open will directly cost you points on the database integrity section of Assignment 2. I am your module leader, Athir Mahir. Today, we will execute a step-by-step method to lock down your database and eliminate these vulnerabilities entirely. To start, you need your tools ready. Open MySQL Workbench version 8.0 or higher and load your practice schema so you can actively apply these steps. This diagram outlines the exact roadmap for our tutorial. We will construct our defenses across 3 specific pillars: domain constraints, entity constraints, and referential constraints. By applying these 3 theoretical rules in Workbench, you replace a fragile schema with a relational model that enforces mathematical consistency across every table. Step 1 is establishing entity integrity. This rule requires every table to have a unique, non-null primary key. Enforcing this allows us to satisfy second normal form, a structural rule ensuring that all non-key attributes depend entirely on the whole primary key. This table shows the exact consequence of ignoring entity integrity. Look at the blank ID row for the customer named Angel. Because the primary key is null, the database has no way to uniquely identify or retrieve this specific customer record. This is the MySQL Workbench table editor. To fix this, open this view and isolate the target ID column. Navigate to the column details, check PK for primary key, and NN to enforce not null. With those boxes checked, entity integrity acts as your database's identification system. You guarantee that no record can ever become anonymous or lost in the system. Step 2 requires applying referential integrity. This step is mandatory to achieve third normal form, a rule requiring that every non-key attribute depends only on the primary key, rather than other non-key attributes. We enforce this using foreign keys. A foreign key is a column in a child table that directly matches a primary key in a parent table. This prevents orphaned records. If a parent record is deleted, the database blocks the action, maintaining the relationship. Open your child table, like orders, and select the Foreign Keys tab at the bottom. First, type a name for the key. Second, select your referenced parent table. Third, check the target column that binds them together. Pay close attention here. The data types of your linking columns must be completely identical. Attempting to link an integer to a varchar is the most common failure point and will immediately generate an error. Referential integrity ensures that your data strictly remains synchronized across tables, preventing orphaned records and maintaining consistent relationships. Step 3 is domain integrity. This satisfies first normal form, which dictates that every cell must contain a single atomic value drawn from a valid set of possible inputs. This table shows a critical domain integrity failure. The text string 697ABC has been submitted into the salary column. The database rejects this because text is an invalid data type for a numerical calculation field. To prevent this, return to your Columns tab. Assign strict data types to every column, forcing the system to only accept formats like decimal for prices or varchar for names. You can further secure your data by adding additional conditions. You can set default values for empty fields or apply check rules. A check rule is a condition that validates data before saving it, allowing you to enforce boundaries like ensuring a price is always greater than 0. Domain integrity acts as a filter for your data, rejecting values that do not match specified formats before they can be stored in your tables. Now that your constraints are in place, you must actively test them using the internal logic tools built into MySQL Workbench. Navigate to the top menu bar, click Model, and select the Validate command to run the diagnostic tool. Read the console output at the bottom of your screen. A mathematically sound model will confirm 0 errors. If issues remain, the console will flag the exact broken rules, allowing you to quickly isolate and fix issues like mismatched data types or orphaned keys. The resulting ER diagram provides visual proof of these rules, showing the primary key icons and the solid lines representing the relationships you just defined. Your final step is to save your .mwb file and capture precise screenshots of your validated model. You will submit these images as direct evidence for Assignment 2. By methodically applying entity, referential, and domain constraints, you have successfully completed the implementation of your integrity rules, resulting in a validated database architecture. Good luck with your assignment.